Well, good morning, everybody. So, yeah, my name is Daniel Campbell. I'll be talking about MBD. I mean, really focusing on semantic model-based definition and what does it mean? What's kind of some of the key data that we need to be thinking about when talking about model-based definition. So, my name, is Daniel Campbell. I'm the president of Rubypoint. I'm also the chair of the QIF working group and a member of the DMSC board of directors. I've been pretty active in the QIF standard for quite some time, really since its inception, since before it was even called QIF. And so a lot of what I'm talking about today in this talk, I mean, first of all, it's kind of a fundamental idea of some background on model-based definition, but I'll be talking a lot about some of the standards that the DMSC provides, particularly the model-based characteristics standards and the QIF, the Quality Information Framework. Rubypoint, my company, is a technology consultancy company in the area of especially model-based definition and QIF characteristics, a lot of what I'm talking about today. So let's get into it. So when we talk about model-based definition, really the essence of what we're talking about is that we want to exchange data between product engineering and downstream, as it's sometimes called, especially manufacturing and quality. And there are other areas like sustainment and so forth, but we'll just focus on manufacturing and quality, kind of a couple of the big domains. But I do think that in a lot of the conversation that's had about this topic, model-based definition, the industry needs to do a better job articulating precisely what model-based definition means. What is it particular to model-based definition that will solve some of the problems that we have? And I think that in the last few years, there has actually been a lot of progress in articulating that vision. And really what it is at its core, what we're talking about is the idea of characteristics. So I think a lot of people have heard about the model-based characteristics standard, the idea of obviously a bill of characteristics and so forth. But starting to think, if there's one thing that I'd like everybody to come away with here today, is the importance of the notion of characteristics as business objects. Just as you might track data in your PLM system related to your part, to start thinking about characteristics as another data object that you want to track in your business systems. And so right now, we have this valley of death between product engineering and manufacturing and quality. And the way that that communication is currently done is meetings, maybe a lot of guessing or making assumptions about what the upstream designer or the downstream manufacturer is thinking. PDF reports or PDF documents being passed around back and forth, or crazy Excel spreadsheets with macros and Visual Basic written in them and things like that. And it's just a very poor way to be able to transmit this data between engineering and manufacturing. And again, the essence of what it is it's characteristic data related to your part. And so I think there are three really big issues, problems that are manifested here in this valley of death that I think are worth bringing up. First is the manual nature of handling of this data. So if you have a drawing, right, you have your characteristics annotated out on your drawing, you go downstream, let's say to a CMM, somebody at the CMM side is going to be re-entering that data into your CMM. So that's the kind of manual handling of the data I'm talking about. That's very costly, and I think that's the first thing that people think about right away. People talk about MBD, the first thing they think is automation. That's what we need to be, that's the benefit we need to be targeting. And I think it's true, but actually I think it's maybe one of the less valuable sort of value propositions of good data interoperability. The next thing would be, the inconsistent processing of characteristics by people, by engineers. And so what I mean by that is just with a paper-based system, first of all, you're relying a lot on natural language, just English prose, and a lot of it is written ambiguously, or it might be very confusing. And so if you have a young engineer, let's say, and a very experienced engineer, you give them the same data, they'll process that in two totally different ways. And obviously everybody knows that repeatability is at the core of a good manufacturing enterprise. And so anytime you have a situation like that, a lack of uniformity in the process that you're able to implement, that's a big problem that you want to address. And so really the solution that we should be going for is a deterministic software-based approach to the handling of characteristics so that every time you have a certain input, you have the exact same output every time. And the third item here, no visibility of characteristics across the enterprise. I mean, so really what we're talking about is just, let's say that at the top level there's a certain product that has a certain type of features, a certain connector or whatever it might be. And you'd like to get some type of a sense of, maybe what it costs. You might like to look into what some of the quality issues are coming up. You'd like to do a study to do some type of a Pareto analysis and see what some of the lowest hanging fruits are to improve it. If you don't have easy access to that data, it's very difficult to do such a study. And obviously on the converse, if you do have access to very rich data like that, it's very, very easy to get instant sort of Pareto analysis of, what are some of the lowest hanging fruits that I can improve in my process. So these are all problems that we're facing right now that need to be addressed in terms of better handling of characteristic data across the enterprise. And actually, towards the end of this presentation, I'll be getting a little bit more into some specific examples of some of these workflow items. So let's get into a little bit articulating what the solution needs to be. I mean, so what's the solution? A digital thread. Oh, great. What does that mean, though? Okay, so with a digital thread, I mean, what we're talking about is that in certain domains, we have very, very amazing point technologies, whether it's simulation tools, design tools, metrology tools, manufacturing tools, very powerful tools in those domains. The digital thread is the ambition to be able to connect all those domains and allow those tools to communicate with each other and pass data back and forth and to basically share their intelligence with each other. That's what the objective of the digital thread is. And so how do we do this? Again, the natural answer everyone will say, well, it's MBD. And maybe you say, well, it's machine readable MBD. Okay, but what does that mean actually? And really what we're talking about is the second block here. It's exchanging of characteristics. So the model data itself, the geometry, that's been a pretty a commodity technology for quite some time. I mean, STEP AP 203, STEP AP 214 have been very, very successful in those areas, and it's basically a non-issue. So what we're talking about is the annotations, the PMI. But these aren't just arbitrary symbols that are just thrown on a screen that don't mean anything. No, I mean, these are discrete characteristics, and someone should be able to look at a drawing or an MBD model and identify a fixed number of characteristics that should be derived from that data set. And again, ideally, this should be a deterministic process where for every time you look at a certain drawing or a model, everyone should come up with the exact same analysis of what are the characteristics that are resulting from that product definition. That's very much not the case right now. You give the same drawing to 5 different engineers, you're going to get 5 very different FAI reports. And that's a big problem. And so, I mean, I think the conclusion here is what's in bold there, that the idea of semantic characteristics, that's the core building block for the digital thread. I mean, when we're talking about this idea of, what we loosely talk about as MBD, really what we're talking about is semantic characteristics as being the atomic unit of data for this type of digital thread operation. So with this information, I mean, what do we do? How do we go from here? And I think what's important here is not to think, this is kind of a top-down analysis, and that's good. You need to have a top-down plan, but we need to think about implementing from the bottom up. In other words, think about specific use cases where you would make use of your characteristics, and how those use cases actually should work, and what you're trying to accomplish, and then from there you can come up with your implementation plan for how to implement digital characteristics throughout your enterprise. So with that, I'm going to get into a little bit of explaining model-based characteristics, a standard from the DMSC that talks about, in sort of general terms, the idea of what is a characteristic, how do you identify a characteristic, what's some metadata that you can attach to a characteristic. Yeah, I mean, the funny thing about this standard, it's called model-based characteristics, because really it was intended, it had in mind the idea of the digital enterprise, model-based definition. But actually, it's important to note that the principles outlined in this document absolutely apply to drawings as well. I mean, it's really more about the idea of characteristics. And so the essence of this standard is about, how do we track characteristics? I mean, that's number one. How do we track them? How do we identify a discrete characteristic so that we can track it across our enterprise? And then secondly, what's some of the most common metadata that one would want to attach to a characteristic? And what's a standard way that we can sort of specify that metadata? So here is this highlighted portion right there. That's kind of what we're talking about in terms of a lot of what model-based characteristics added. So the most important thing is the characteristic ID. What's called the balloons. Sometimes these are called balloons, because the traditional way of doing this is you grab a paper drawing, you get a red pen, and you start, ballooning your characteristics and putting a number on them. So this idea of these characteristic IDs, that's the number one thing. And that's really the most important takeaway from this standard, is just applying these IDs to your characteristics. And by applying them, obviously what that means is that also implies that we have discretely identified exactly what our characteristics are. So that's really the key important step. And then it specifies these different augmentations that can be applied to the characteristics in the form of criticalities, product requirements, verification plans, and so forth. So here's the start of it. There would be an annotation, maybe you'd have a position tolerance or size tolerance or something like that. And then next to it, we'd find a symbol like this, okay? And this sort of hexagonal shape is what it recommends. But the essence of what it's saying is that there's a product characteristic, and so it has this optional PC prefix that could be added to it. But it's number 41, 041. So that's the sort of human readable balloon, human readable ID for that particular characteristic. And that's the core for this these model-based characteristics. Another piece of metadata that can be placed next to it is the product. It's called the product requirement association. And so this would be a reference back to a requirements. It might be a systems model or maybe something indoors that specifies a functional requirement maybe, or maybe it's a pointer back to some a risk, like a design failure mode or a design risk that the tolerance is intended to mitigate against. Whatever the source of that particular annotation, the reason for that annotation, that could be referenced here. And so in this example, it's just REQ-ME-044. So that would be the ID of some requirement that's driving this particular characteristic. Next is the criticality classification. So first of all, you could specify a level, high, medium, low, let's say. You are also additionally able to specify a category, like it might be safety, for example, or regulatory, or appearance. These are sort of, and actually multiple items of these. Those are unranked criticality categories and multiple, you could choose more than one of them. And then there's a space for caveat, which is just sort of free-form text that one might want to apply. And then there's also the area of the verification plan requirement. And so here we're really talking about a couple things. One is what's called the method. And so that might be, it's basically what type of, inspection method you're going to be using. Might be maybe CMM or caliper, for example, something like that. You can specify the sampling plan, and in this case, it's specified 100%. We're going to inspect 100% of our parts for this particular characteristic. And then there's also the ability to specify the context. So in other words, like for this case, we might say FAI 100%, but then once we go into production, it's going to be 10%, 10% of our parts or something like that. And so that's the verification plan requirement. And so this is the type of metadata that's built into the standard that gives some sense of how to apply this type of data. Actually, the idea would be that this is applied in CAD on the product definition, and how to attach this type of metadata to a characteristic. So that's a summary. That's a real high-level summary of the model-based characteristics standard. At the end of this, there's a QR code where you can go and you can find the link to the standard if you want to go and read it in more detail. But that's really the essence of it. So again, just the idea is you're identifying what your characteristics are, and then providing some basic mechanism for being able to attach metadata to them. Next, another important standard in this area is QIF. So QIF kind of builds on top of model-based characteristics. They're very complementary. Model-based characteristics is agnostic of what the delivery vehicle is for the data, whether it's QIF or STEP or native CAD or some proprietary tool. Model-based characteristic is about the idea of characteristics. QIF is a specific way that we can carry data, specifically characteristic data, across different domains. So you've probably seen this diagram here, the QIF library. It has all these various domains, starting from MBD, plans, measurement plans, resources, meaning what devices do I have available to do inspection, rules, just kind of best practices that you might enshrine. DMIS is mentioned here. That's not QIF, but it is another sister standard to QIF that's governed by the DMSC, and it's linked. It's sort of been harmonized with QIF. And then we have QIF results for capturing actual inspection data, and then statistics for being able to carry out some statistics on the data. So that's QIF there in a nutshell. That's what that's the sort of the domains that QIF can satisfy. But what's important to QIF, I think the main thing that people should understand about the heart of QIF is the idea of features and characteristics. And these are the core ideas. Again, I've been talking about characteristics, but also features. When you're talking about what is a characteristic, it's some type of a control on some portion of your CAD model. Usually a face, maybe it's an edge, but you're referencing some portion of the geometry, and you're saying, I'm controlling this with a position tolerance. I'm controlling this with a profile tolerance, and so forth. And so in QIF, the features and the characteristics are really at the core of the data model. Everything's built upon that. There are a number of different explicit types of characteristics or features. We've got cylinders, planes, opposite planes, lines, et cetera, et cetera. And what it does, the idea of a feature is that it abstracts what the underlying CAD topological definition of the feature is. So in this case, what we're pointing at is a cylinder made up of two half-cylinder faces. So it's common in CAD. It happens, very often. But when you're holding a physical part in your hand, you don't have two half surfaces. You have a hole. And so what's really important here is that I have a hole, and I put a size and a position tolerance on it. The fact that it's made up of 2 surfaces or 3 surfaces or 20 surfaces is totally irrelevant. So we're abstracting that and coming with the idea of what the feature is. I think the other important thing to point out about features is that it could be a word that a lot of people trip up on, because in every different domain of software that deals with CAD, there's a different use of the word feature. And this is confusing to people. In CAD, for example, if this was a blind hole, usually a hole will include the bottom of the hole, right? For what we're looking at here, let's say that there, like I said, there's a position and a size pointing to this. In that case, you would not want to point to the bottom of the hole. You're not controlling the bottom of the hole with the position. You're controlling the hole of the cylinder with the position. And then obviously once you get to CAM will have its own set of features. And so it could be a little confusing, but the point is that in every different domain, it'll have its own sense of features. But the one thing that all the features share is the underlying geometry. So that allows you to understand the relationship of one feature to another, whether they share geometry or not. Maybe 2 features from different domains are actually perfectly identical. Maybe one of them is a subset of another. Maybe they just overlap slightly. You can do this kind of analysis. But yeah, so this idea of abstracting the metadata that you're applying in QIF into features is a very, very important concept here. And then the other important key concept is characteristics. So again, there are a number of explicit types of characteristics. Obviously all the GD&T controls, surface finishes, welds, all these things. These are all different manifestations, specific types of characteristics that could be instantiated in QIF in a semantic way. And so the core relationship of features, characteristics, and CAD is shown there on the left. Characteristics point to features, which allows the characteristics to be abstracted from the CAD representation of the geometry, and then the features point to the CAD. And so that's kind of a very important construct of how we layer the data in this type of a system. And so that's about QIF. I mean, that's really all that I want to get across about QIF. Is just this idea of features and characteristics. It's at the heart of the implementation. So we've looked at just sort of general idea of what it is that we want to, what is the problem that we want to solve. When we talk about MBD, that's really just a real shorthand way of saying that we want to manage our characteristics across the enterprise. Model-based characteristics is a good standard to help us start thinking in those terms. QIF is one of various different standards that's able to carry that data in a digital way. So let's do a little bit of looking here and start thinking about, okay, characteristics. Where am I actually using characteristics right now in my enterprise? And I don't necessarily mean digitally. I mean just the idea of characteristics is, someone's looking at a drawing and mentally extracting the characteristics from the drawing and doing some type of a decision-making based on the implied characteristics that person has extracted with his human judgment. So let's look at some of these examples, because these are all ripe cases for us to be able to begin to digitize and allow for characteristic data to be exchanged through all these different systems. And so we'll look at a few different areas. We'll look at, starting upper right, we'll look at some design kind of domain areas, some manufacturing domain areas, some quality areas, and then getting a little bit into data analytics. Just to come up with some examples. And I'm going to go really quickly through this. I don't want to get into any really detail on a lot of this. Tolerance analysis, right? Very important. And this is how, obviously at the core of how we're determining what the values of our characteristics are, especially relative to each other, and how they satisfy the function of the product that we're trying to make. DFM, design for manufacturing, or costing analysis, a lot of that is also very dependent on what are the tolerances that I have. Are they super tight tolerances? Are they very loose tolerances? Getting into requirements, tracing requirements, doing DFMEA analysis. This also is a mapping of our characteristics to requirements to understand what some of the criticalities are for some of our characteristics. And then, yeah, I mean, I added the idea of just characteristic management here. The idea of I want to be able to start managing characteristics in my PLM system, which is kind of an emerging technology over the last 5 years with various different PLM vendors really getting into that field in a serious way. Looking into manufacturing, so where are some areas here? The first one here on the far right, we got sort of characteristics flowing to process plans, flowing to work instructions. I mean, this is something, you know, there aren't very good digital approaches for this right now, but this is where characteristics are used. Someone's doing an analysis of the characteristics on the model, coming up with loose process plans for how we're going to go about making this part that will satisfy those conditions. And then from there, turning around and generating specific work instructions based on those characteristics that are going to be sent out to the shop floor. So again, juggling characteristics there. CAM, same thing. You know, am I just going to drill this hole, or do I need to bore it and then maybe even hone it? Depends on the characteristics that are applied to that hole. And then, yeah, even getting to, you know, welding. Of course, you know, you look at the welding symbols, you understand the welding characteristics. Looking at assembly, same thing. They're often, you know, a sort of assembly characteristics that come into play. Quality, I don't need to spend a lot of time on this because I think this is the clearest one, I think, to people why characteristics matter. You got CMM, other types of inspection, you know, whatever they might be. And then management of characteristics, generating quality plans like first article inspection documents and so forth. Data analytics. I mean, so this is a really important one. All of these systems that we just looked at, many of them are generating lots of data, which would be useful to the other domains. And then a lot of them would be able to really heavily take advantage of some of the data that's coming from the other domains. Let me just give one example, just because I see it right here, tolerance analysis. So your tolerance analysis is initially going to be set up with some set of assumptions about your production distributions and things like that. What if you could very, very easily gather inspection data that's traced through your proper digital characteristic management and be able to take that inspection data and feed it back into your tolerance analysis system? And you could update your tolerance analysis based on what your production distributions actually are and start to optimize your part design based on that. I mean, it would be groundbreaking. And in theory, it's possible to do, but it's so much effort right now to do such a study that in practice, it's very rarely done. But I mean, we could think of any number of cases of this. Actually, there was a very good presentation yesterday. Stephanie Laux-Hartle and Nathan Holyuk presenting on the idea of data coming out of CAM, actually, tracing data coming out of CAM, empty connect data, and audio data, and how they maintained characteristic traceability data and tagged their audio data and their empty connect data with the features that they were machining at that current time. And then we're able to do some data science on that data to understand, you know, and correlate it to the metrology data, actually, to get some understanding of what was going on at that moment on the machine tool, such that they could correlate it back to what was going on metrology-wise. So this is a big, big, big area where digital characteristics could really benefit. So that's really all I had for today. I mean, here are some links for everybody for the QIF standard and for MBC. And again, I think you know, the main takeaway, I think, for everybody is just having a sense that managing characteristics in a digital way is really what we're talking about when we say the shorthand term of model-based definition. And I think it's good for us to start, you know, thinking, how are we going to progress industry in this way? And actually, how can each of you at your own companies, how can you start to try to push the limits of how you're doing that internally? And with that, I'd like to open up any questions.
Thank you.